Okay, so today's lesson we're going to talk about the rock cycle. So here in this diagram, we're kind of looking at a part of the rock cycle and just how rocks are constantly changing. So we know igneous rock, it's formed when magma or lava cools. Those rock fragments and sediments can be compacted or cemented to form sedimentary rock. And then both the igneous and the sedimentary rock can form metamorphic rock under high pressure and heat. Okay, so here we have some heat causing metamorphic rocks. We have some cooling here to form those igneous rocks. We have weathering and erosion for sediments. We have compaction and cementation, which will form sedimentary rocks. And then those sedimentary rocks can become metamorphic rocks, again, very gradually at depths of 5 to 25 kilometers. And heat and pressure is required for that change to metamorphic rock. So as rocks sink back into the depths of Earth's crust, the heat and pressure can turn them back into magma. And then all rocks can be broken down to form smaller rocks, fragments, and sediment. So human activity is responsible for some of the breakdown process, but most of it does occur naturally. So looking at this diagram here, if we start here at sedimentary rock, under heat and pressure, it can change to metamorphic rock. If that metamorphic rock melts, it becomes magma. It can be cooled to form igneous rock. When there is weathering and erosion, that produces sediments. The compaction and cementation, we're back to sedimentary rock. All right, but weathering and erosion can occur, forming sediments, and then compaction and cementation to form sedimentary rock again. Here, metamorphic rock can undergo weathering and erosion to form sediments, and so on. All right, so that is showing how rocks can change in this rock cycle. Okay, so we just finished watching this video. So it just showed us, again, the rock cycle and how rocks can change from one type to another. So techniques for identifying rocks. Rocks can sometimes be identified simply by their appearance. However, if they've been exposed to rain, wind, extreme temperatures, their color and appearance may have changed. So one step in identifying rocks is to determine from which mineral or combination of minerals they are made, and usually they have to be observed under a microscope to determine those minerals. Next, we're going to talk about sediment and soil. We did talk about soil a little bit when we were doing Unit 2. So sediment, it can be compacted or cemented to form sedimentary rock. It's a slow process. It can take thousands of years to occur. But what happens to the sediment in the meantime? So some sediment, as we saw in the video, it gets carried to the ocean. Other sediment will become soil. So how does a soil form? So Earth is covered by a layer of rock and sediment. Plants and animals, they will add organic matter. So organic matter consists of things like leaves, twigs, dead worms and insects and organisms. All right, so that organic matter will then create spaces that can be filled with air or water. And all of that will combine to form soil. It's a material that can support plants. Climate, the type of rock, and the amount of moisture will influence the soil formation. Even if there's a slope of the land, that will also influence soil formation. Small living creatures, like we saw when we were doing Unit 2, like microorganisms, bacteria, earthworms, so on, that are living in the soil or they invade the soil, they can speed up the process of soil formation. So when we talk about compost, that's the part of the soil that's composed of dead plant matter, humus, That's that dark colored part of soil. It's rich in nutrients like nitrogen, phosphorus, potassium, and sulfur. And if soil is fertile, it contains those nutrients needed for plant growth. And it's called fertile soil. Okay, so in this diagram, we are looking at some weathered rock fragments. They contain lots of cracks and spaces, so it provides areas for air and water. Then here, some immature soil. It can start to support small hardy plants. Those will then attract insects and other small animals. And then over time, dead plant material and animal material that will build up. Then bacteria and fungi will cause them to decay. That decaying organic matter will form a layer on top of the weathered rock. Then we have mature soil. It will contain lots of mineral-rich clay on top of weathered rock. The clay forms when water carries the minerals away from the decaying organic matter and then mixes with the weathered rock fragments. Soil profiles can take thousands of years to form. This is a description of the characteristics of the different layers that make up a particular soil. So basically those different layers, they will show different degrees of soil evolution. So when we look at soil profiles, you'll see that it varies in structure and appearance depending on its depth. So here is a soil profile. It's of an eroded hillside. Top layer is called topsoil. It's dark colored, rich soil. It contains humus and small grains of rock. That layer has undergone the greatest number of changes from the underlying rock layer. B, this area here. So we were at layer B. It's lighter in color because there's little to no humus. It contains minerals that have leached from the top layer. Leaching is the removal of soil materials that have been dissolved in water. Water will react with humus to form an acid. That acid can dissolve elements and minerals from the upper layers and carry them through the spaces in the soil to the lower layers. And then C here, that is the bottom layer. Partly weathered rock and minerals that are leached from above. It closely resembles parent rock below, and it's at the very beginning of the long, slow process of rock evolving into soil. All right, so last video here on what is soil and why it's important. Just going to pause this.